44, this one's rather challenging. What is the first thing to do always? To try to factor out a GCF. And the GCF in this case is what? Just 2. So if you pull out 2, now it can't be x because there's no x's in all the 3 terms. It's just a 2 because there's a multiple of 2 in the 4 and the 14 and the 12. There are no x's in all terms. So let's pull out a 2, and we're going to have a 2x to the 4th minus 7x squared plus 6, correct? Still equal to 0. And technically, since this is an equation, it's equal to 0, I could do whatever I want to an equation as long as I do it to both sides. So if I wanted to, I could divide by 2 here, cancels, divide by 2 here, and you're going to end up with 2x to the 4th minus 7x squared plus 6 equals 0. So I made this equation a little bit nicer. It's still a 4th degree trinomial. And once again, when you have a 4th degree trinomial, if you have a 4 here and a 2 here, you could make it look like a quadratic. You could pretend that it's a quadratic and do your parentheses. And instead of x right here and x right here, what do I put? X squared. X squared and x squared. However, the a value is 2, so you can't have an x squared and an x squared. Right? You'd have to either put a 2 right here and a 1 right here, or maybe it's backwards, a 1 right here and a 2 right here, or a negative 2 and a negative 1, so it gets confusing. So we're actually going to have to use that longer method of when your a value is not 1, you have to do that multi-step factoring process. So step 1 on that multi-step factoring process is to multiply a times c. So when you multiply a times c on the above quadratic, well, it's really a quartic, but we're treating it like a quadratic, is 12. Okay? And step 2 is to think of the multiples of 12 that combine together to give you the middle value, negative 7. So you could just make a list: 1 times 12, 2 times 6, 3 times 4. Those are all the different ways of getting 12. And if you think about it, the only pair of numbers that'll actually combine to give you a negative 7 is 3 and 4. But it's a negative 3 and a negative 4. That's the only way it'll actually combine together to give you a negative 7. So the right pair of numbers is negative 3 times negative 4. And that's the answer for step 2 on this longer factoring process. So what we're going to do is step 3 is to rewrite your whole equation, but instead of the b value, you're going to replace the b value with the negative 3x squared and a negative 4x squared. In other words, we're going to take this trinomial and make it into a polynomial, make it into 4 terms. Now, why do I want to do that? So I could apply the grouping method, factoring by grouping method. So I really have the 2x to the 4th. Instead of minus 7x squared, it's going to be a minus 3x squared minus 4x squared, which is really the minus 3x squared and the minus 4x squared. It's really a total of a negative 7x squared. So I'm just rewriting it, and I still have the plus 6 at the very end, and we still have the equal 0. So now I need to factor this polynomial by grouping. So the first thing to do would be to make space between your first 2 terms and your second 2 terms. So there's my space. I took the first 2, moved them over, second 2, moved them over. There's my space between them. In the first group, what could I pull out? What's the GCF in the first group right here? What's in common in both terms? X squared. So if we pull out an x squared, what would we have left on the inside? 2x squared minus 3. Okay, and in the second group, what's in common? What could I pull out? There are no x's in both terms, but you could pull out a 2 for sure, and it's better to pull out a negative 2. Check it out. Pull out a negative 2, and what would be left? It would also be a 2x squared minus 3. Now let's not forget about the equals 0 that keeps coming down. So the whole purpose of factoring out what's in common, is to look at your first group and your second group and realize I have the same exact binomial in both first group and second group. So I'm going to take this 2x squared minus 3 and pull it out of the whole thing. So let me zoom out a little. I want to take that 2x squared minus 3 and put it out here in the front. 2x squared minus 3. And if I pull out the 2x squared minus 3 from each of those groups, what do I have left? The x squared minus 2. That's right. Now, obviously, these parentheses are exaggerated, so let me write them the correct size. So I have factored. It took me a long time, but I've factored. Now, why did I want to factor it? Why do I want to end up with multiplication instead of the original polynomial? Well, I want to end up with multiplication because when I have something times something equals 0, I could use the zero product property to split them and set them each equal to 0. So that's exactly what I want to do. I want to take the 2x squared minus 3 and say that it's equal to 0. And I'm going to take the x squared minus 2 and say that it's equal to 0. Now the first equation, it's easy to solve. Well, they're both easy to solve. Let's take it one step at a time. We're going to add 3 to both sides. You're going to end up with 2x squared equals 3. Final step would be, well, actually not final step, but the next step would be to divide both sides by 2, and you end up with x squared equals 3 over 2. Are you with me? Now we're still not done because x is not by itself. This is an x squared. And if I want to get rid of the square, what would I have to do? Square root is correct. So let me move this up more, and let's take the square root of both. Now, when you apply a square root in an equation, you're going to have to put a plus minus, well, I'm sorry. You have to put a plus minus right in front of your answer. So we have x equals, no more x squared, it's just x. We have a plus minus, and now we do have the square root of 3 halves. Now, we need to remember how to simplify this. You're going to have to split the root to the top and to the bottom, okay? So you really have x equals plus or minus the square root of 3 over the square root of 2. Now the problem is you cannot leave radicals in the denominator. We don't want the square root of 2 in the denominator. So we're actually going to have to get rid of that square root of 2 in the denominator by multiplying both top and bottom by the square root of 2. So I really have x equals plus or minus on the top, the square root of 3 times the square root of 2. You could actually put that together as the square root of 6, and on the bottom the square root of 2 times the square root of 2, that's really the square root of 4, which is actually just the nice beautiful number 2, no more square root. So right here we have 2 answers. X equals plus square root of 6 over 2 and minus square root of 6 over 2. Technically those are decimal answers. They're ugly decimal answers, but they still are real answers. So we already know that it's going to cross the x-axis at least twice if we were thinking of the graph. Let's go back up to the other equation, the x squared minus 2. That one's a lot easier. You're going to go plus 2, x squared equals 2. Final step would be square root, x equals, don't forget about the plus minus, square root of 2. So we actually have 4 answers. They're all ugly decimals, but we know for a fact that those 4 answers means that they have 4 x-intercepts. So if I were to, man, this is a lot of work, but if I were to have graphed this quartic trinomial equation, I already know my end behavior because the a value is positive, both of them are opening up, and it would cross the x-axis exactly 4 times because there's 4 real answers. And I could even give you a good decimal approximation. If you just type in the calculator square root of 6 over 2, that'll tell you where it's going to cross the x-axis, both on the positive value and the negative value. Same thing with the square root of 2, both at the positive and the negative. I hope this helps.